All right, page 2. We're basically told that we have an average watermelon weight of 320 ounces that's normally distributed with a standard deviation of 5 ounces. So what I do is I come down here and I draw my normal distribution curve. All right, so that's going to look like that. Okay, we were told that my average is at 320. Then I need to draw 3 lines on both sides. 1, 2, 3. 1, 2, 3. Okay, I'm going to add 5 because our standard deviation is 5. So I've got 325, Percy no, 330, 335. Now I'm going to subtract 5. I've got 315, 310, and 305. All right, so now let's go ahead and put in these percents. I think that's going to be really useful for us. So this is going to be a 34.1, a 13.6, a 2.1, and a 0.1. And same thing the other direction, we've got a 13.6, a 2.1, oops, I missed my 34.1 again, 34.1, 13.6, 2.1, and 0.1. There we go. All right. Let's see if this works. It doesn't. All right, so let's go back up here. It says, for a sample of 2,000 watermelons, how many watermelons should have a weight greater than 310? Okay, well, we have to find that percent. So we're looking to add up from here to here. So I'm adding up the 13.6, the 34.1, the 34.1, this, and the 0.1 as well. All right, so going ahead and let's do that. So that's going to give me 13.6 plus 34.1 twice, plus another 13.6 plus a 2.1 plus a 0.1, and that gave me a 97.6. Now we know that we have a sample of 2,000 watermelons, so I'm going to multiply my percent, which I convert to a decimal, 0.976. I'm going to multiply that by 2,000, and that's going to give me 1952 watermelons. All right, here we are. All right, so now on that same group, how many watermelons should be in the 315 to 330 ounce range? So 315 to 330. So now we're talking about, oops, I went a little bit far. 315 to 330. So we're talking about adding up this one, and that one. When I do that, let's go back. When I do that, I get a 34.1 plus a 34.1 plus a 13.6 gives me 81.8%. So converting that 81.8% into a decimal, I get 0.818 times my 2,000 watermelons is going to give me 1636 watermelon. Okay, not sure what's going on there. All right, what's the probability that when picking a random watermelon, you would pick a watermelon greater than 335 or less than 305? Well, let's go ahead and look where that is. Greater than 335 is that 0.1, and less than 305 is that 0.1. So really, we're just talking about 0.2%. So 0.2%, that's 0.2. Okay, and that's 0.2% out of 100. Just going to multiply both the numerator and denominator by 10, and I get 2 over 1,000. Now I'm going to divide both by 2, and I get 1 over 500. That's my probability. All right, next one says what weight would correspond to a z-score of 1.7? Well, we have to write down our formula for x. That's x equals z times standard deviation plus x bar. So I know that my x is going to be equal to my standard deviation of 1.7. That's given to me right here, times the standard deviation, which is given to me in the problem as 5. Okay, and then we're going to add our average, which is again given to us in our problem. And that's going to be 328.5 ounces. All right, next one says using the percentile rank to z-score conversion chart, how much would a large watermelon have to weigh to be in the top 18%? Well, if we're in the top 18%, what percentile are we in? Well, it has to add to 100, so we're in the 82nd percentile because we are better than 82%. That's why we're in the top 18%. All right, so I'm going to go to that chart, and I'm going to find 82%. I find my z-score with 82 is going to be 0.93. All right, so I'm going to go back and complete this problem. So I have a z is equal to 0.93, and now I can complete the problem. So I've got x equals my z, right? I'm using this formula right here. My z of a 0.93 times my standard deviation of 5 plus my average of 320, and that gives me an answer of 324.65 ounces. All right, thanks for watching page 2.